Good evening, everyone.
Oh.
My name is Wang from
No, it's
Harbin Institute of Technology. My topic is dislocation mechanism-based viscoplastic model, coupled with Gurson type damage model for P91 steel creep life prediction. My topic is include 5 parts. Firstly, P91 steel was widely used as structural materials in power plants. The parameter failure, such as type 4 cracking, usually occur when creep loading is applied. This phenomenon is related to microstructural evolution coupled with macro deformation. So the main objective of the present work is to understand the deformation and the failure mechanism in dips and develop a reliable mechanical model to accurately predict creep life for safety purpose. P91 steel have complex microstructure, package, block, and last with nanoscale precipitates such as Cabbage precipitates and MX precipitates. Dislocation evolution and precipitated evolution play an important role in creep deformation. For dislocation, evolution included 2 parts: accumulation and annihilation. Accumulation mechanism hardening the materials, and the annihilation mechanism softening the materials. In long-term creep service, precipitates should become coarsening. This is the reason for materials failure. So above all, we can know deformation process are closely linked to the microstructure evolution. So in our research, creep failure is caused by void evolution and high stress range and high temperature. The void nucleation can be divided into 2 parts: particle-based nucleation and particle-free nucleation. At high level stress, the particle matrix cohesion is mainly nucleate mechanism, and at low stress range, void nucleation will happen at grain boundary nucleation at discrete boundary and in the grain. So this is my constitutive model from rock. Our constitutive model from rock is based on Gurson damage model. The yield function gives the relationship between macroscopic stress, matrix effective stress, and porosity. This is the key formula in GT model. Another key formula is plastic dissipation rate. Based on plastic dissipation, global stress strain and matrix effective stress strain established connection. Void evolution included 2 parts: growth and nucleation. Nucleation in our research is governed by plastic strain rate, and the nucleation is followed by normal distribution. There are 2 criteria for void nucleation related to cohesion: energy criterion, stress criterion. The energy criterion is the relation strain energy must exceed the surface energy. We can see the nucleus strain is size independent parameter, and for stress criteria, the local stress must equal to the stress required for the interface to cohesion. The key formula is local dislocation density increase linear with local strain. So we can say the nucleation strain is size dependent. In our research, we use the second one. The plastic flow rule of the matrix material at block level, creep deformation is controlled by dislocation glide. We use Taylor homogenization method to get the plastic flow rule of the matrix at micros level. The slip resistance can divide into two parts. Dislocation induced resistance and precipitation induced resistance. The dislocation density rate can be divided into two parts: dislocation accumulation and dislocation annihilation. The dislocation annihilation mechanism include precipitation and forest dislocation locations effect. For annihilation mechanism, the annihilation mechanism distance is governed by this formula, or which shrink the distance is temperature dependent. In long-term creep service, precipitates causing mechanism is very important. The governing formula is that the parameters in our model is listed as this. All the parameters the value is from this reference. All this reference is almost studied materials is P91 steels. Only few parameters needed to calibrate. We use uncoupled diameter model to calibrate flow parameters, which define the steady slip resistance when 1% creep strain. So we get the steady state creep rate. We calculate relative difference. Use this formula. We can see the temperature factor is included. We calculated the damage parameter by calculating fracture time compared to experimental data. And in this part, only 4 parameters needed to calibrate. This is our modeling results. From this picture, we can see our model can accurately capture the creep rupture time at high stress strain and temperature range. And this is another validation, another type of validation. We can see our model is work well in predicting creep strain and creep strain rate. Above all, we can draw a conclusion. Our model can accurately capture the creep life, creep strain, and the creep strain rate. So we can use this model to conduct some similar work. Firstly, we focus on microstructure evolution during creep failure process. From the left picture, we can see void nucleation occupies the majority of the creep process. Only when the creep generate reach a certain level that the factor of void growth become apparent. From the right picture, we can see the size, the carpet precipitation causing significantly. And then we talk about the effective initial microstructure on creep raptor time. We can, from the first two pictures, we can see the carpet precipitates have significant influence raptor time. And at high stress range, and the MX precipitation and the dislocation density void volume fraction is have a slight effect. And then we further investigated the effect of cushioning mechanism on creep. The solid line is included the cushioning mechanism, and the dotted line is exclude the cushioning mechanism. We can see from these two pictures, the cushioning of the precipitation has a significant impact on static creep rate and the rupture time. We use this formula to calculate the creep nucleus stream with different precipitation size and temperature. We can from two pictures we can know that the side of the precipitation had the most significant impact on the nucleus stream. And finally, we use our model to develop a new lifetime assessment tool. Traditional assessment tool typically use the Lasso-Miller relationship, and at here we use our formula to calculate the nucleation time to display here as a comparing. Another way we define remaining time which equal to calculated fracture time minus precipitate cushioning time. So the result is the right picture. So this is my conclusion. Thank you for your attention.